Remember this? 8 systems. We care about whether these systems have memory, are causal, are stable, are linear, are time invariant. Okay? And we got to figure what's happening here. A couple I really want to point to is this system here. What happens as the rocket takes off? Its mass is changing over time. It has something relative to time as a separate variable. The mass, we read all the system equations in Physics 1. That mass is not a constant, it's an m of t. It's like this t variable. So that's time variant. If I start the clock when it's on the ground versus when it's in the air, over time it's changing. So it matters where we start the clock on this experiment. Same thing with this. As the spool winds out, the mass changes. Okay. Stability. Have you ever been in the auditorium where this guy gets too close to the speaker? You get feedback. If we're considering volume out versus volume in, our input is our volume here, our output is our volume here. Bounded input, bounded output. You're not shouting loud. You have a very bounded volume you're feeding in. But because of the way the system works, the volume coming out becomes unbounded until the system breaks. And, people shut things down or whatever. So this would be an unstable system. Okay. So we've got some time invariant, we've got some other systems. We've got this one here. You'll see that in the homework assignment. Causality. Okay. It's all people are looking into the future when they make their decisions here. The future affects the current. Even though we don't know exactly what it is, we predict what it is. So we have causality issues here. How we will analyze each of these systems. If you're designing an automotive carriage, if you're designing the mechanics that are happening for these systems, if you're analyzing the financial market, if you're looking at this system, knowing these system properties, which of these properties each of these systems has, will determine how you analyze it further on. It's part of the initial stage of the analysis procedure. And you kind of see how those 5 system properties apply to a semi-realistic series of systems. Sort of. There's not totally this intangible list of 5 definitions you need to memorize. You can see that they are applied to something. Hopefully as the semester goes on, we'll see better as to why and how, but this is trying to give you at least a starting point. That they are not just 5 definitions that you're being told to work out because I'm mean. I might be mean, but that's not the reason. Okay. They do apply to realistic systems, and all these systems are systems that as an engineer you could be expected to work with. Okay. Thank you very much for your patience.